So, good morning to all of you. We are almost end of this divide and conquer technique. So, probably today we would like to discuss last but one uh, algorithm. That algorithm is merge sorting. Only one algorithm is left over for us. That algorithm is what is that? Defective chessboard problem. One more algorithm is defective chessboard problem, which is left over with us. Probably by tomorrow or day after tomorrow, we shall finish up this particular unit. And we would like to take some revision. I mean, only complexity revision by day after tomorrow. So 3 or 4 classes coming. 2 or 3 classes will be used to close off this particular unit. And by Friday, today it is Tuesday, by Friday, we will get start the unit number 3, that is the greedy method. Okay, greedy method will be get started by the Friday. However, this is the agenda for making ourselves to have a clear idea before going to start the work. And yesterday or in the previous class, we have taken the general explanation regarding to evaluation of Pixar algorithm in both perspectives. Perspective number 1 will be in terms of average case kind of thing, and best case and average case kind of thing, that is the unlogin. And the worst case, how worst case will be gets calculated, that's also be taken in terms of Pixar while it is being evaluated. Now today we will get starts with one more new algorithm. It's very important algorithm because the divide and conquer is actually introduced by the person who introduced this algorithm. He's the pioneer of computer science. After Charles Babbage is father of computers, and after Charles Babbage, he is the father of modern computers. Modern computers in the sense, the computers which are working with the help of a microprocessor. Okay, he was proposed a huge theory to the computer science. So he is also identified the number system, binary number system. So based on that, the computers are being working out. Okay, let us see what is that. So, however, merge sorting technique, and we'd like to take remarks in the sense we need to recall, or we need to remind the people whomever created this particular application, and when it was created, what are the different aspects of this algorithm. That is called as remarks. So let us take the remarks here. So remarks will be Sir John von Neumann. So John von Neumann is the person who introduced this particular algorithm, and of course this technique also, divide and conquer technique, also introduced by him only, Sir John von Neumann in 1952. Actually, in 1942, he was introduced a theory for computers. So computers might work based on a binary number system, and it could not be understand the high-level language such as English, Telugu, or some other languages cannot be understand. Whatever the processing which could be done by computers will be only based on binary number system. This proposal was made by him. Based on his proposal and based on his papers, which have been printed in IEEE journal, based on that, many companies have made some kind of research, and they have come up with. I mean, one of the companies, the company Intel. Intel company has come up with a processor that is 4004 processor. So, and it was meets the requirements of Sir John von Neumann. Therefore, the first and foremost electronic computer was prepared by Intel Corporation, and the microprocessor version is 4004. Of course, it was happened. The story was happened in 1948. However, our point is we like to discuss about only merge sort algorithm. And the sorting algorithm was introduced in the year 1952 by one of the pioneers of computer science, is John von Neumann. It is clearly, very clearly, whatever the divide and conquer has specified, what is the exact algorithm which was given by divide and conquer in its general method. Same kind of approach will be gets followed by this met sorting algorithm. There is no deviation, even single deviation is not there. So wanted to divide the list of elements exactly half, yes, it could be done. But if you consider so binary search or min-max algorithm, or what is the algorithm we have discussed just before, that is fixed algorithm. Fixed algorithm can be identifies mid element by taking a pivotal element. Okay, and then binary search also we do the same. So and then if you consider min-max algorithm, that could be divide the entire problem into so two partitions until number of elements will be equal to 2. If number of elements will be equal to 2, small of p will be get satisfied. So there are some kind of one or two violations are there in all algorithms, but there is no violation in met sorting algorithm. No violation at all. No violation at all. Everything. What is the general method which has been given in the divide and conquer general method? Everything has been followed. Let us see. And it is the basic disadvantage, pitfall of this particular problem is extra space can be used. That is the basic problem. Extra space can be used. So in terms of using of extra space, it is very, very, very weak in terms of storage. Huge amount of storage can be used. Look at this, huge amount of storage can be used. So that is the problem with them. And whatever the complexity cases you have, average case, worst case, best case, whatever the case it might be, so it will be always taken n log n only. Even two elements are there that can be divided and can be applied. Conquer operation will be gets operated. Okay, so therefore it could be always used n log n only. There is no other complexity. Then in terms of running, it is because n log n is very, very, very lesser value when compared to so big O of n square. Worst case complexity of fixed is n square. Okay, if your elements will be given in either it is non-descending order or descending order. So these two cases will be there, then it will be gives you order of n square or big O of n square. Okay, so as far as running time complexity, MetSat is very, very effective. But because of this particular point, this is the point here. Because of this particular point, people are not using this one very much. So if you have some 1 terabyte of information is there with you to start, it will be required 1 more terabyte for doing the same operation. So that is the basic problem with the divide and conquer approach. So therefore, because of this particular reason, people are not used. But he has given, so John von Neumann has given a new idea to the world, a new innovative idea to the world, so that many other applications have been emerged. However, that's what I have said at the previous, just before spoke to you. MetSat closely follows the divide and conquer approach because John von Neumann has created this approach and he was created algorithm also. So that is why it is very much closely it has been followed. What is the problem actually? Problem is, so there is a particular algorithm, merge sort, which will be taken low and high as parameters. Based on this one, so we have to identify mid element and can be divided into many number of subproblems, provided n will be number of elements will be greater than 1. If number of elements will be equal to 1, low and high will be gets equal. Therefore, single element is there with you, and that element is already solved one. So there is no question to divide that particular problem into further pieces. Okay. So n is greater than 1. Yes, divide operation will be done, and many subproblems will be generated. I'll give you one example, then you could understand. Then conquer operation will be done So this particular divide and conquer, basic synthesis of divide and conquer is it is always executing. So the recursive calls will be gets happen. So same thing will be gets followed by this particular merge sort also, and then combine. So what is the combine in the sense? So merge one more what do you call the function, apply merge and get the original solution on merging of all subproblems. On merging of all subproblems, so it has been gets the original solution. What is the synthesis actually? What actually been happening here? The divide operation will be always done with n by 2 sublist, n by 2 at each recursive call. And the conquer is always trying to call merge sort algorithm for number of times using a recursive manner. And then finally combine, merge all those lists into single list by so step-by-step manner. This is actual synthesis. Every time it could be divided the list into half, and so on. Okay. This is actual synthesis. This is actual problem. This is actual synthesis. Let us go ahead and take the example. Yeah, example could be taken into consideration. Look at this. We are applying divide operation. So here n number of elements will be, these are the n number of elements. So I haven't created any other list for you. I have taken the same list which you have taken in the min-max algorithm. So as like as min-max algorithm, I have taken here. Same elements have been taken. Look at this. Totally 9 elements are there, and here, so divide operation will be always taken. So it will be taken. Mid will be equal to so first plus last divided by 2 by taking the floor value. Floor value will be, this is the floor value. So look at this, this is the floor value. Taking floor value, it could be taken. As far as this one, 9 plus, first is 1 and 9 is the last. 9 plus for 10, 10 divided by 2, that is 5. So therefore, 1 to 5 is one sublist, 6 to 9 is another sublist. Look at this. 1 to 5 is one sublist and 6 to 9 is another. And continue this process until every list have single element. Every list have single element. Okay. So do the same process for several number of times until so you got the small of p will be get satisfied. So here small of p cannot be satisfied because this sublist is having more than one element. Here also the same situation. And here the same situation, more than one element, that is 3 elements are there. Here 2 elements are there. And here also same situation. So divide operation cannot be completed. Now you have to operate one more time for getting the same 2 elements and single element, and here it is one element, and so on and so forth. Operation will be done in such a fashion here. Look at this. So at this place, so single element is there. So here small of p is satisfied for this subproblem, and here also small of p will be get satisfied. Here also small of p will be get satisfied. Here also satisfied, and so on. So all these things will be get satisfied because every element does have, every sublist does have single element. And here it is not yet satisfied. So therefore continue for divide operation for this particular sublist only. Therefore you got 10 and therefore you got 2. Now if you consider all sublists at leaf level, everything is having single sublist. And one thing you need to understand here, why MEDSAT is not used by the people? What is the basic reason which is not used by the people here? Let me give you the explanation in that particular perception here. So here, for example, totally 9 elements are there. So for example, let us consider 18 bytes are supposed to be used here. 9 into 2, 18 bytes. Okay, 18 bytes are supposed to be used. So here you could observe, here it is 5 elements, so 10 bytes will be taken. So these 18 bytes will be there at one particular problem. and 10 more bytes is required for this sublist, and so 8 more bytes are required for this particular sublist. 8 in the sense, because of integers I am taking, size of integers, each size of integer is 2 bytes. 9 into 2, 18. So here it is 5 into 2, 10. Here it is 4 into 2, 8, something like that. So this could be stored somewhere else. Somewhere else in the sense in the memory only, not exactly anywhere else. It is in the random access memory only. For this one, 6 more bytes are required. For this one, even decomposition, divide operation will be done. So the memory will be gets used. So here it is 4 bytes. So here it is 4 bytes. Here it is 4 bytes. And again, here it is 4 bytes. And everything will be 2 bytes. 2 bytes. So let me calculate everything and then understand how much amount of memory could be required to do the same business here. Look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 18 bytes at the leaf level. 18 bytes plus. So here it is 4 bytes will be required. And so 4, 4, 4. 12. Let me write it as 12 here. Directly 12 here. So let me write directly 12 over there, so that you could it's very easy to write 12 bytes, and here it is 6, and here it is required 6. Here it is in the level 1, so 18 bytes, and the level 0, 18 bytes. Calculate how many number of 36. 18 plus 18, 36, 42. So 52 plus 2, 54. 54 plus 18, 64, and 72 bytes are required for this particular simple problem. For this particular simple problem, we require 72 bytes. Actually, what is actual list storage data? That is 18 bytes only. You require actually 18 bytes, but doing same operation with mid sorting, you require 72 bytes. Okay, so that is why, as far as memory point of view, merge sort is very, very, very inefficient. It needs huge amount of space to perform the operation. So that is why people are not using this one for operating any sort operation on the records. Though it is very efficient, because huge amount of memory cannot be supplied to the algorithm. However, this is what is the aspect of memory usage. That how divide operation is just completed, then how conquer and combine or merging operation will be gets completed here. Let us see. So conquer and combine. Look at this. So at the leaf mode level, these are the two elements. I mean, list 1 and list 2, two elements are there here. So if you consider this particular list, only one element is there already in sorted order. It is also in sorted order. While combining them, take the element of first list and take the elements of the second list, compare them, which is minimum that can be taken into first position and could be taken into second position. And do the same process for list number 3. It is also in sorted order. So because here it is only one element is already sorted order. While combining, here 2 elements are there, here 3 elements are there, one element is there, and compare each other and can be combined. So at each and every level, while combining 2 sublists into single sublist, that single sublist is already in sorted form. Okay, already. So sort and match, and so on. Then you take this way. So here also say 6 and 90 sorted order. So here also take all these elements. So while combining this one or while merging this one, compare 7 with 6. 6 is minimum element, so 6 will be first position, 7 will be second position, and 10 will be third position, 25 will be fourth position, 90 will be last position. Perform the same operation at right side also. So 5 and 2, 6 sublist is 5, and the 7 sublist is 2, and combine these two to 5. While merging, we have to operate sorting also. Okay, here also same procedure will be done. And while combining these two, so apply the same procedure. 2 is minimum most element, will be first element, and 3 is the next element, 5 and 8. And finally, this could be get started in such a way. While sorting this particular sublist and this particular sublist, compare each other. So 6 is greater than 2. Yes, it is. So therefore, 2 will be the first place. Again, 6 is greater than 3. Yes, it is. So 3 will be second place. Again, 6 is greater than 5. Yes, it is. So 5 is the third position. 6 is greater than 8. False. Now it will be taken. It will be taken and placed here. Okay. Then 7 is greater than 8. No. Then it will be taken and placed here. 10 is greater than 8. Now it could be taken and placed here. So and so on and so forth, it could be done. The merge operation will be taken care about the sorting and merging. Okay, merge sort and merge. Two algorithms have been given. Merge sort will be always taking care about the divide operation. After division gets completed, merge will be taken care about. So merge and combine. So sort and combine. Sorry, sort and combine. One moment. Okay. So taking like this, and you have to perform. Believe that you do understand. If you are still at any questions, then watch this video one more time. Still, you have questions. So post your questions in Google Classroom. I'll answer them. Okay. Now, what is the algorithm? Let us take the algorithm here. Method A number of list of elements. Low will be the first element. High will be the last element of that particular sublist. Okay. So if low is less than high, then we will go ahead. Met equal to lower of low plus high by 2. Same operation. A low to mid is one sublist, and mid plus 1 to high will be another sublist. After completion of these recursive calls, when it could be gets completed, so each and every element, each and every sublist does have single element. 1 is less than 1, false. 2 is less than 2, false. So 6 is less than 6, false. I'm talking about this particular condition. Okay. So if you consider one particular sublist, so which does have only, for example, some 3, list index value is 3, here it is 10, for example. So you have to send this particular sublist to merge sort. So what is the low value and what is high value? Low value is the same. So and the high value also same. So 3 is less than 3, which is false. So therefore, small of 3 will be gets satisfied. In such a way, merge sort will be gets operated for number of times until each and every sublist might have single element. Then after completion of these recursive calls, this division operation gets over. So then it will be operated merge. This merge will be causes or take responsibility to combine, conquer and combine. Conquer and combine can be done by merge. Okay. So next one and close. That is what about merge sort. Merge is very big value, big kind of thing. So you please go through this. I don't want to explain this one because it could be taken huge amount of time to explain. So that is why I just want to take. So I'd like to write a program for you on merge sort, and I'll send that particular program to you. Then you have to execute in our copy the program and paste in our compilers, then execute it. Okay. This is the complete algorithm for merge sort. Merge will be taking care about both so conquer and combine. So both conquer and combine will be taking care about taking care by merge. So here divide operation will be taken care by this particular merge sort. Okay, merge sort. So here every time we are using temporary location B. Every time you are using temporary location B, you would identify here. Same temporary kind of list is being used here. So this temporary uses will be taking huge amount of space. So look at this. After completion of everything, so we have to recopy the same list into original list and it will be sent to the user. Okay, and it could be sent to the user over there. So that is the point where exactly, so we have to consider in such a way. Okay, so please go through this particular algorithm for a while, and I'll let you continue. Okay, so to perform first merge sort, it could be taken T of n by 2, T of n by 2. To perform second merge sort, it will be taken T of n by 2 again. So to perform merge operation, for doing this particular merge operation, so it could be taken C into n. Okay. For example, so here we have sent n number of elements. If if you consider to send n number of elements for the first time, then C of n. Okay, C of n for applying merge. Okay. So you can consider what is C here in the sense C will be after completion of complete merge, then you have to take or collect entire list into original list. And for doing this whole business, it could be a whole business in the sense right away from while to up to this particular end. So then it will be taken n linear kind of operation. Linear complexity will be taken right away from this while to this end here. And for doing this particular thing, so n number of C number of operations will be took place. Okay. So apply this particular operation in terms of thing. Already we have learned this one in Pixar. Oh, I have copied from Pixar and I was not eliminating Pixar. Metsat actually Pixar, whatever the average case for Pixar, so that can be taken. Look at this same. If anybody missed about Pixar average case analysis, you please go through here. Okay. Here also we have the thinking that elements will be distinct. So if elements will be get so distant in the sense, the worst case running time will be taken for n elements, and either descending order or non-descending order or random order. Of course, random order is not supposed to be taken. I mean, descending or non-descending or random order, everything will be gets okay. Then for this one, case one. So number of elements are exactly equal to 1. Then the element is already sorted. So therefore, we are not supposed to perform any extra operation here. So therefore, T of n equal to 1, which is 1, equation number 1. Okay. Then followed by case 2. Only 2 cases are here. So elements, the list is having more than 1 element. That is, n is greater than 1. Then, and also consider any order, not exactly random order, any order, whatever the order may be, order is not important for us. Any order. Then T of n equal to T of n by 2 plus T of n by 2 plus Cn. On solving this equation, you could get T of 2T n by 2 plus Cn, equation number 2. And n by 2 operation will be T of n by 2 will be equal to 2T into n by 2 into half, that is n by 4 plus C into n by 2, equation number 2, 3. And solve the T of n by 4 also, equation number 4. Hope that everything is, you have recall yourself from Pixar, everything is set. Then, so equation 3 and 4 will be substituted in equation 2, then you could get something like this. 2 into 2T of n by 4 plus C into n by 2, therefore plus Cn, therefore it could be seems like this. 2 into 2, 2 square, this 2 into this 2, 2 square, and this 2 will be cancelled by this particular thing. So therefore 2 square T of n by 4 plus Cn plus Cn, 2Cn. And 2 square into n by 4, n by 4 value will be substituted here. 2 square into 2T n by 8 plus C into n by 4, C into n by 4 plus 2Cn. 2 square into 2, so 2 square into 2 will be so 2 cube, And this 2 square will be gets cancelled with 4. So therefore Cn plus 2Cn, that is 3Cn. Therefore 2 cube plus n by 8 plus 3Cn. Convert all the values, possible values to 2 powers, then it could become something like this: 2 cube plus n by 2 cube plus 3Cn. And compute the same thing for k recursive calls, then t of n equal to 2 power k, t of n by 2 power k plus kcm. Then it will be equation number 5. Then what is the basic primitive of the divide and conquer approach? This is the basic primitive. As far as the hypothesis of divide and conquer approach or strategy, if a number of elements will be greater than 1, then k recursive calls will be required. Hence, after k recursive call, small of p will be satisfied or returns true. Therefore, your sublist, leaf level sublist must be having single element as far as, of course, Pixart or Metsart is concerned. This is the general hypothesis or general synthesis of divide and conquer. Based on this particular theory, we would like to consider n equal to 2 power k. Okay. What does it mean? N by 2 power k equal to 1. That is the meaning. Equation number 2, 1, small 1, and apply log base 2 on both sides. You will get this. Log base 2 n is equal to log base 2 2 power k. Then finally you could get k equal to log base 2 n. Okay. Then this is equation number 2. Then substitute equation number 1 and 2 in equation number 5 in this particular equation. Then you could get n into t power n by n plus log base 2 n into cn. Instead of k, log base 2 n into cn will be taken. Instead of 2 power k, so n will be taken here. So instead of 2 power k, n will be taken. Instead of k, we have substituted this particular value here. If you solve this particular operation, this particular thing, t of n by n equal to t of 1, t of 1 equal to 1 as per the first equation. So therefore, n plus log base 2 n into cn. When compared to, so cn into log n, so n is very negligible value. It is very small value. Therefore, we have to eliminate n from the specific operation or specific complexity. Then we'll go ahead with n log n. So c is a constant actually. Since constants are not supposed to be taken into consideration of any calculation of complexity, so therefore, so c will be gets eliminated. Already I have given some information why constants are left over. When constants, while eliminating constants, you please remember the swap operation. Actually, swap is 3 fundamental operations, but as far as the calculation of complexity, swap will be taken into single operation only. It is not 3, it is single. So that is why constants are supposed to be eliminated. Therefore, you could get this value. So finally, t of n equal to n log n, or t of n equal to big O of n log n. So this is the final conclusion. Okay, this is the final conclusion. In this way, you have to solve the complexity of merge sort. Complexity of merge sort will be for the worst case, average case, and whatever the case it may be. If you give 2 elements, look at this. If you have given 1 and 2, apply the same divide and conquer approach of this one. So this will be divided into 1 and 2. Yes, small of p will be satisfied. Then apply conquer and combine. Okay. If you give 3 elements, 1, 2, 3 will be given. Apply divide and conquer. So here, so 4 by 2, so that is 2. So 1 and 2 will be the first list, and 3 will be second sublist. So 1 and 2 in the C here, small of p cannot be satisfied. So therefore, so it could be divided into 1 and it could be divided into 2. Okay, however, divide and conquer strategy is strictly followed. So that is why every case kind of operation will be big O of n log n only. You may be asked one question in our final examination. Please write this particular question. Explain the algorithm which does have n square as worst complexity and n log n as average case complexity. I repeat, explain. So the question will be seems like this. The question will be asked to you like this. So in this way they will ask you. So explain the algorithm and its complexity for which worst case complexity is big O of n square. So here unable to write n square here, so that is why I have taken like that. And average case complexity as big O of n log n. Okay, if you are supposed to ask something like this, you have to answer with the quicksort. Okay, so please remember this question. Okay, so this is for today's class. Everything gets over. Today's class is MedSort. MedSort is a very important sorting technique. Of course, people are in real time. MedSort is not supposed to use. Okay, please remember. And tomorrow, defective chessboard problem will be discussed. Then followed by a revision for one class, how to evaluate min-max complexity using paintbrush. I don't want to go through this one. Using paintbrush, I have to write each and every point for you. Okay. Don't go away. I'm taking the attendance of you. Yeah. Thank you. So probably this weekend I have to give one test, online test, as a JNTK online test. Probably this weekend I shall give you a link to you through Google Classroom. Everyone must attend that particular test without fail. If anybody will be failed, so those marks will be reflected in our final examinations also. Please remember.